Saturn is eating its rings. That is not a poetic image. It is a measurement. Every second, thousands of kilograms of ice slide out of the most famous structure in the solar system and fall into the planet below. An invisible rain that no photograph has ever shown, draining an Olympic swimming pool's worth of water roughly every half hour. And the rings are only the first secret. At Saturn's North Pole, a storm shaped like a near-perfect hexagon, wide enough to hold two Earths side by side, has been turning without change for more than 40 years, and no one can fully explain why it exists. The planet's magnetic field is aligned so flawlessly that a 90-year-old theorem says a field like that should not be able to sustain itself. And until 2019, nobody on Earth knew something as basic as how long a day lasts there. The calmest looking planet in the sky is the one hiding the most. By the end of tonight, you will know exactly why Saturn is the scariest planet in the solar system, and why it is not even close. Get comfortable. If you enjoy discovering that the most familiar things in the sky are the ones keeping the biggest secrets, a slow like and subscribe helps this channel reach more curious minds like you. Because after tonight, the beautiful planet, the one every child draws, will never look calm to you again. Now, let's slowly settle in. There is a planet that every child on Earth knows how to draw. Ask a 5-year-old to draw a planet, any planet, and you will almost never get Mars or Venus or even Earth itself. You will get a circle with a ring around it. You will get Saturn. Of all the worlds circling our star, this is the one that became the symbol, the one that stands in for the very idea of a planet, printed on lunchboxes and stitched onto backpacks and hung from the ceilings of classrooms. And there is a reason for that. Saturn is the only planet in the solar system with a ring system bright enough to see from your own backyard. A modest telescope, the kind that costs less than a bicycle, will show it to you on any clear night when Saturn is up. People who see it for the first time through an eyepiece often say the same thing. It doesn't look real. It looks like a sticker pasted onto the sky. It looks too perfect. Tonight, that perfection is the subject on trial. Because over the last 4 decades, nearly every close measurement we have made of Saturn has come back with the same quiet message. The perfection is not what it appears to be. The calm is not calm, and the planet that looks the most serene, the most composed, the most finished of all the worlds we know, turns out to be the one keeping the most secrets. That is the case this video will make, slowly, piece by piece, and by the end of it you will understand not just why Saturn is the scariest planet in the solar system, but why it is not even close. Let us begin with Saturn's voice. In the early 2000s, a spacecraft called Cassini was closing in on Saturn after a journey of nearly 7 years. Among its instruments was a device built to listen to radio waves and the waves that ripple through charged gas. As Cassini approached, that instrument began picking up powerful radio emissions pouring out of the planet, generated by the same processes that light up Saturn's auroras. Radio waves are not sound. They are light, of a kind our eyes cannot see, and in the emptiness around Saturn there is no air to carry any sound at all. But radio waves rise and fall, and those rises and falls can be shifted into the range of human hearing, the way a translator carries a sentence from one language into another. A team at the University of Iowa did exactly that with Cassini's recordings, and the result became famous. If you have ever heard it, you have not forgotten it. Rising tones and falling tones, long whistles that bend and dissolve, sweeping cries that climb over one another and never resolve into anything, never settle, never repeat. It sounds, people said, like a haunted house. It sounds like something calling from very far away. Scientists were careful to say what it actually was, an honest translation of natural radio emissions from a giant planet's magnetic environment. And yet the feeling it produces is hard to argue away. The most beautiful planet in the solar system, the serene one, the one from the children's drawings, opens its mouth, and this is what comes out. Hold on to that feeling, because it is the first honest data point of the night. And now, let us put the planet itself on the table. Saturn is the 6th planet from the Sun, orbiting at an average distance of about 9.5 astronomical units. An astronomical unit is the distance from the Earth to the Sun, so Saturn circles our star nearly 10 times farther out than we do, at a distance of roughly 1.4 billion kilometers. Distance does strange things to light. Sunlight that reaches Saturn is only about 1% as strong as the sunlight falling on your window, and the light that bounces off Saturn's clouds takes about 80 minutes to crawl back across the gulf to your eye. Think about what that means. Every time you look at Saturn, every time anyone has ever looked at Saturn, you are seeing the planet as it was more than an hour ago. You have never seen Saturn as it is. You have only ever seen where it was and what it was, 80 minutes in the past. For a planet we will spend tonight accusing of hiding things, it seems fitting that even its image arrives late. The planet at the end of that stale light is enormous. Saturn is the second largest world in the solar system, wide enough that you could line up more than 9 Earths across its face, and massive enough to outweigh 95 Earths. It takes 29.5 years to complete one orbit, which means a person born on Saturn, if such a thing were possible, would celebrate their first birthday in their 30s. Its axis leans over at almost 27 degrees, a little more than Earth's tilt, so Saturn has seasons just as we do. But each of those seasons lasts more than 7 years. A winter at Saturn's pole is 7 years of darkness. Remember that number. 7 years of polar night will matter a great deal later in this story. And yet for all that size, Saturn is barely there. This is the first crack in the portrait, and it is worth slowing down for. If you could somehow measure out 1 cubic centimetre of Saturn, averaged across the whole planet, it would weigh about 0.69 grams. The same cubic centimetre of water weighs 1 gram. Saturn is the only planet in the solar system less dense than water, and the old textbook image is irresistible precisely because it is true. If you could build a bathtub large enough, Saturn would float in it. 95 Earths of mass spread so thin that the whole world would bob on the surface like an apple. The planet that looks like a solid golden globe is, by the numbers, closer to a puff of gas wearing the costume of a world. That thinness shows up in its shape too. Saturn spins very fast, completing a rotation in a little over 10.5 hours, and because it is so light and so fluid, that spin flings its middle outward. The planet measures about 60,000 kilometres from its centre to the equator, but only about 54,000 from its centre to the pole. It is nearly 10% flatter than it is wide, the most flattened planet in the solar system, and the difference is large enough to see with your own eyes in a photograph. Saturn is visibly squashed. It does not even hold the shape we draw it with. So already, before we have touched a single mystery, the familiar picture has begun to slide. The solid globe is a fog lighter than water. The perfect circle is a flattened ellipse. The serene silence is a chorus of unearthly radio cries. None of this is frightening on its own. Every fact in it has a clean explanation, but it establishes a pattern, and the pattern is the real subject of tonight. So let me say it plainly, once, so that you can test it against everything that follows. The quieter Saturn looks, the more it is hiding. That is a suspicion, not a verdict. A planet cannot be convicted on a strange voice and a low density. So here is the plan for the night, the full case, laid out in order. First, we will go to the rings themselves, the most famous structure in the solar system, and discover what they are actually made of, because almost nothing about them is what it seems from a distance. Then we will follow the rings downward, along invisible lines of force, into a discovery from the last few years that quietly rewrote their future and their past. We will meet the machine that made these discoveries possible, a spacecraft that spent 13 years circling Saturn and paid the highest possible price for what it learned. We will travel to the planet's north pole, where a storm in the shape of a perfect hexagon, wider than 2 Earths, has been turning for at least 40 years, and where the honest scientific answer to the question of why is still, in part, we do not know. We will sink beneath the calm golden clouds into winds faster than any hurricane in recorded history and storms that circle an entire world. And then we will go deeper still, to the strangest fact of all, a property of Saturn so exact, so flawless, that according to one of the oldest theorems in physics, it should not be possible for it to exist. A perfection that is, in the most literal sense, against the rules. Any one of these things alone would make Saturn interesting. It is the combination, the way each secret protects another secret, that makes Saturn something more than interesting. By the end of tonight, you will see all of them assembled in one place, and you will be able to judge for yourself whether the word scariest is an exaggeration. I do not believe it is. I believe the calmest face in the solar system is a mask, and I intend to show you, measurement by measurement, what is behind it. So let us start where everyone starts. Let us start with the thing you already think you know. Those rings, the ones from the drawing, the ones that made Saturn the most recognizable world in the sky. Here is the first question of the night, and it sounds almost childish until you try to answer it. What, exactly, are they? The first human being ever to see Saturn's rings did not understand what he was looking at, and the confusion he wrote down 400 years ago turns out to be one of the most quietly prophetic mistakes in the history of science. In the summer of 1610, Galileo Galilei pointed his newly improved telescope at Saturn. The instrument was crude, a tube with lenses that magnified perhaps 20 times, and through it Saturn did not look like a ringed planet at all. It looked like three objects huddled together, a large body flanked by two smaller ones. Galileo wrote with complete sincerity that Saturn appeared to have ears. He had discovered something no human eye had ever seen, and he had no framework, none at all, for what it could be. Planets were points of light. They did not have handles. Then it got worse. 2 years later, in 1612, Galileo looked again, and the ears were gone. They had simply vanished. The strange triple planet had become an ordinary disk as plain as Jupiter. We now know exactly what happened. Saturn's rings are tilted like the planet itself, and twice in each 29.5-year orbit, the rings turn exactly edge onto the Earth. Because they are so absurdly thin, a fact we will come to in a moment, an edge-on-ring system reflects almost no light, and effectively disappears from view, even in a good modern telescope. It happened again as recently as March of 2025, but Galileo knew none of that. All he knew was that a feature of a world had been there, and now was not, and the sentence he wrote to describe it has outlived every telescope he ever built. Has Saturn, he asked, swallowed its own children? He meant it as bewilderment, borrowing from the old myth of the god Saturn who devoured his offspring. He could not have known that he was writing down, in 1612, a nearly perfect description of a real physical process that would not be measured for another 4 centuries. Hold that phrase. Saturn swallowed its children. We will need it again before the night is over, and when it returns it will no longer be a metaphor. It took 45 years for someone to solve the puzzle of the ears. In 1655, the Dutch astronomer Christian Huygens, using a better telescope, proposed that Saturn was surrounded by a thin, flat ring that touched the planet nowhere. He was right, and from that moment on the image was fixed. The circle with the ring around it entered the human imagination and never left. But here is the thing about that image. The one on the lunchbox, the one in the drawing. It shows a solid object, a hoop, a band of something continuous, like a wedding ring scaled up to the size of a world. And that is not what the rings are. It is not even close to what the rings are. Move in close, closer than any telescope on Earth can take you, and the smooth golden band dissolves. There is no surface there. There is no solid anything. What you find instead is a crowd, a swarm of individual objects so numerous that the count runs into the billions and perhaps the trillions, every single one of them a separate body on its own separate orbit around Saturn. Most of them are chunks of nearly pure water ice. Some are the size of a grain of sand, some are the size of a pebble, or a fist, or a beach ball. Some are the size of a car, and a few are the size of a house, tumbling slowly, colliding gently, drifting apart again. Spectroscopy, the science of reading materials by their light, tells us the rings are at least 95% water ice, which is why they shine so brilliantly. They are not made of rock or metal or dust, not mostly. They are made of the same substance as the ice cubes in your freezer, scattered into a cloud of fragments beyond counting, and lit by a distant sun. Now give that swarm its true dimensions, because this is where the familiar image breaks completely. From the inner edge of the main rings to the outer edge is a span of about 282,000 kilometers. To put that in perspective, the distance from the Earth to the Moon is about 384,000 kilometers. Saturn's main rings, laid across that gulf, would stretch nearly 3/4 of the way from your window to the Moon. And yet, and this is the number that should stop you, that entire continent spanning sheet is, in most places, somewhere between 10 meters and 1 kilometer thick. Often it is just tens of meters, the height of a modest apartment building. The proportions are almost impossible to hold in your head. If you shrank the rings down until they were as wide as a large city, their thickness would be less than that of a single sheet of paper. It may be the thinnest large structure known to exist anywhere, a veil hundreds of thousands of kilometers across and in places no taller than a house, and the veil is not still. Nothing in it is still. Every particle in the rings obeys the same laws that govern any moon or satellite, which means the closer a particle orbits to Saturn, the faster it must move. The inner edge of the ring sweeps along at more than 20 kilometers every second, while the outer regions travel more slowly. So the rings are not turning like a solid wheel, all together. They are flowing, the inside forever outrunning the outside, lane after lane after lane of ice moving at its own speed, like traffic on a highway with a billion lanes and no exits. From a distance, this river of fragments blurs into a smooth, motionless disk. That smoothness is an illusion of scale. The most placid-looking feature in the solar system is a torrent. Look closer still, and you find that the river is being sculpted. The rings are full of gaps and grooves and sharp edges, thousands of them, and many are the fingerprints of Saturn's moons. The most famous gap, the Cassini division, is a band nearly 4,700 kilometers wide, visible from Earth as a dark line in the rings, and it is swept clean by rhythm. A particle orbiting in that gap circles Saturn exactly twice for every one orbit of the moon Mimas, farther out. Twice per lap, on schedule, Mimas tugs it in the same direction, and the tugs add up, like pushing a child on a swing at just the right moment, until the particle is pulled out of the gap entirely. A dark stripe thousands of kilometers wide, drawn by nothing more than a small moon keeping perfect time. Elsewhere, the sculpting is even stranger. A tiny moon named Daphnis, only about 8 kilometers across, ploughs along inside a narrow gap of its own, and its gravity drags the ring edges upward into peaks of ice, 1.5 kilometers tall, real mountains hauled out of a sheet thinner than the moon itself, casting long shadows across the ring plane when the light comes in low. Another embedded moon, Pan, has spent its life collecting ring material onto its equator, building itself a smooth ridge that makes the whole moon look like a piece of ravioli. And at the ragged outer F ring, 2 moons, Prometheus and Pandora, heard the particles between them, and Cassini's cameras caught Prometheus in the act of dipping into the ring and dragging glittering streamers of ice out behind it, a moon vandalizing its own ring, on camera. All of which raises the obvious question, the one a curious mind cannot help but ask. If Saturn has all this ice, billions of fragments, enough to build something, why is it a ring at all? Why didn't it simply gather itself into another moon? The answer is one of the most elegant pieces of physics in the solar system, and one of the most quietly brutal. There is a boundary around every large planet called the Roche limit. Inside that boundary, the planet's gravity pulls harder on the near side of any object than on its far side, and that difference, the tide, tries to stretch the object apart. Far from the planet, an object's own gravity easily wins, and it holds together, and moons can form. But close in, inside the Roche limit, the tide wins. For icy material around Saturn, that boundary lies roughly 140,000 kilometers from the planet's center, and the main rings live almost entirely inside it. Every time ring particles begin to clump together, drawn by their own faint gravity, Saturn's tide reaches in and pulls the clump apart again. The rings are not a moon that failed once. They are a moon that is forbidden, permanently from ever forming, matter caught forever on the wrong side of an invisible line, ground finer and finer by 4 billion years of gentle collisions. What looks like an ornament is, on inspection, a demolition held in perpetual slow motion. And even that is not the whole picture, because while the main rings grind on, something else out there is doing the opposite. Much farther from the planet drifts a broad, faint, ghostly ring called the E ring, and it is not a relic. It is being built right now in real time, its fine, icy grains supplied continuously by geysers erupting from the south pole of the moon Enceladus. We will not linger there tonight, but note what it means. Saturn's ring system is not a museum piece. It is a living machine, with construction happening in one place, and, as we are about to discover, something very different happening in another. Because here is where the night takes its first real turn. Everything I have described so far, the swarm, the thinness, the flowing lanes, the sculpting moons, all of it could still belong to a stable system, a structure that simply persists, beautiful and self-renewing, for as long as the planet lasts. That is what astronomers assumed for most of the 20th century. It is what the serene photographs seem to promise. But the photographs are lying by omission. The rings have a leak. Every second of every day, quietly, invisibly, in a way no picture can show you, Some of that ice is leaving the rings, and it is not drifting away into space. It is going somewhere much closer. It is going down. The life of a single ring particle is a balancing act that never ends. Picture one of them, a knuckle-sized chunk of ice somewhere in the middle of that flowing river we just left. For as long as it remains electrically neutral, its existence is simple. Gravity is the only force that matters to it. It falls around Saturn on a clean, closed orbit, the same path, lap after lap, the way the Moon falls around the Earth. It could, in principle, do that forever. A neutral piece of ice in a stable orbit has no reason to go anywhere else. And if that were the whole story, the rings really would be eternal, and this video would be a much shorter and much less unsettling one. But the rings do not orbit in empty, gentle space. They orbit inside one of the harshest electrical environments in the solar system, and the smallest particles among them are about to be reminded of it. 3 things are constantly working on that ice. First, sunlight. Ultraviolet light from the sun is energetic enough to knock electrons clean off an ice grain, leaving it with a positive electric charge. Second, plasma. Saturn is wrapped in a swarm of charged particles, electrons and ions trapped by its magnetism, and these slam into ring grains continuously, sometimes sticking, sometimes knocking other charges loose. Third, micrometeoroids. A perpetual drizzle of tiny fragments from the outer solar system rains onto the rings at tens of kilometers per second, and each impact vaporizes ice into little bursts of electrically charged gas. Between the 3 of them, sunlight, plasma, and impacts, the outcome is inevitable. Sooner or later, an ice grain stops being neutral. It picks up a charge, positive or negative, and the moment it does, the rules of its existence change. Because a charged particle no longer answers to gravity alone. A charged particle feels magnetic fields, and Saturn's magnetic field is one of the largest and most powerful structures in the entire solar system, an invisible cage of force lines erupting from the planet's interior, arcing tens of thousands of kilometers out through the ring plane and diving back into the planet near the poles. To a neutral boulder the size of a house, that field is irrelevant, and the boulder sails on undisturbed. But to a charged grain of ice dust, the field is suddenly the strongest voice in the room. The grain is seized. Its clean orbit begins to twist. Instead of circling in the ring plane, it starts to slide along the magnetic field line that threads its position, the way a bead slides along a wire. And Saturn's field lines do not go in circles. They go down. They lead out of the rings, down through space and into the top of Saturn's atmosphere at particular bands of latitude, the exact places where those lines of force are anchored in the planet. Follow the bead down the wire then. The grain of ice spirals along its field line faster and faster until it strikes the thin upper air of Saturn at enormous speed and simply ceases to exist as an object. It flashes into vapor, scattering water molecules into the planet's ionosphere, the electrically active layer of the upper atmosphere. 1 grain, gone. And here is the sentence that should change the way you see every photograph of Saturn you have ever admired. What happened to that 1 grain is happening continuously to unimaginable numbers of others, every second, all around the planet at every hour of every day, and it has been happening for as long as the rings have existed. It is a rain, a constant invisible rain of ring ice, falling out of the sky of Saturn into Saturn. The planet is quietly eating its own rings. I want to be careful here because claims this large deserve their receipts. How could anyone possibly know this? You cannot see the rain. That is the point. The grains are microscopic, the flow is spread across a world, and no photograph, not even Cassini's sharpest, shows so much as a wisp of it. The story of how it was discovered is a 40-year detective story, and it begins, like so much of tonight, with Voyager. When the 2 Voyager spacecraft flew past Saturn in 1980 and 1981, their cameras caught something odd in the planet's atmosphere. Subtle dark bands circling Saturn at certain latitudes, like faint smudges on the golden face. Nobody could explain them. Then, in 1986, a scientist named Jack Connolly proposed something remarkable. He mapped Saturn's magnetic field lines and noticed that the dark bands sat at precisely the latitudes where field lines passing through the rings come down into the atmosphere. His suggestion was that water from the rings was flowing down those lines and falling into the planet, seeding the upper air with material that changed its chemistry and darkened it. It was an elegant idea, and for decades that is all it was. An idea. A suspicion drawn on a map waiting more than 25 years for an instrument good enough to test it. The test finally came from a mountaintop in Hawaii. Between 2011 and 2013, a young researcher named James O'Donoghue and his colleagues used the Keck telescope, one of the most powerful on Earth, to study the glow of a very particular molecule in Saturn's ionosphere, a charged form of hydrogen written H3+. That molecule is exquisitely sensitive to what is falling into the upper atmosphere. Water raining in from the rings alters its abundance, which alters its glow. So the team mapped that glow across the face of Saturn, latitude by latitude, and what they found was extraordinary. The glow was not smooth. It brightened and dimmed in bands, and the bands lined up, latitude for latitude, with the footprints of the magnetic field lines connected to the rings. It was the fingerprint Conony had predicted a quarter-century earlier. The rain was real. It had been falling the entire time, in every image, behind every serene portrait, invisible to every camera, and now it had been caught, not by seeing the rain itself, but by reading the stain it leaves where it lands. Then came the numbers, and the numbers are where the unease begins in earnest. When O'Donoghue's team published their analysis in 2018, they estimated how much ring material this charged rain carries into Saturn. The answer came out between roughly 430 and nearly 3,000 kilograms of water every second. Take a moment with that. Even at the low end, that is more than the mass of a small car in ice, leaving the rings and falling into the planet in the time it takes you to say the word one. At the high end, it is closer to the mass of a loaded delivery truck every second, hour after hour, year after year. Astronomers reached for a comparison and found a memorable one. At those rates, the rings are losing roughly an Olympic swimming pool's worth of water every half hour or so, silently, without a trace, while the planet sits in your eyepiece looking like the calmest object in the sky. And even that was not the full accounting, because in its final months, as we'll see properly later tonight, the Cassini spacecraft did something no machine had ever done. It flew inside the rings, through the narrow gap between the innermost ring edge and the top of Saturn's atmosphere, and it carried a mass spectrometer, an instrument that could taste the space it was flying through, molecule by molecule. What it tasted in that supposedly empty gap was falling ring material, and not just water. There was methane, there was carbon monoxide, there were fragments of organic molecules, complex carbon chemistry, sifting down out of the rings in quantities nobody had predicted. This was a second separate drain, pouring straight down along Saturn's equator, in addition to the magnetic rain at higher latitudes. The team led by Hunter Waite published the measurement in 2018, and their estimate for this equatorial infall ran from about 4,800 kilograms per second up to as much as 45,000 kilograms per second during the period Cassini was watching. 45,000 kilograms is the mass of a fully loaded 18-wheeler truck. Picture one of those made of ice and organic dust dropping out of the rings and into Saturn every single second, and you have the upper end of what the spacecraft measured on its way to its own destruction. Two independent drains, then. Two completely different methods, a telescope in Hawaii reading a glow, and a spacecraft physically flying through the fall and catching it on its tongue. Both saying the same thing. The most famous structure in the solar system is leaking heavily from at least two places at once, and the leak runs downhill into the planet. Saturn is devouring its own rings, exactly as literally as those words can be meant. And here is what I find genuinely unsettling about it. More than the tonnage. It is the concealment. Nothing about the rings announces any of this. There is no visible waterfall, no glittering stream, no gap slowly widening while you watch. The rain is carried on invisible field lines by particles too small to see, and it lands as chemistry, not as spectacle. If humanity had never built infrared spectrographs, never flown a spacecraft into that gap, we would still be drawing Saturn's rings as the emblem of permanence, and we would be wrong, and we would have no way of knowing we were wrong. The single most photographed object in the solar system beyond Earth has been dying in every photograph, and the photographs show nothing. Remember the suspicion from the beginning of the night. The quieter Saturn looks, the more it is hiding. We just caught it hiding a river, but a leak, once discovered, forces two questions on you, and they are the two questions that will carry us into the strangest chapter of the ring story. If the rings are draining at up to tens of thousands of kilograms every second, then how much time do they have left? And there is a darker twin to that question, one that almost nobody thought to ask until the measurements forced it. If the rings cannot last forever into the future, then perhaps they have not existed forever in the past. How old, really, are Saturn's rings? The answers to both questions arrived in the same handful of years, from the same dying spacecraft, and they did not just adjust the numbers. They demolished the oldest assumption we had about the most beautiful thing in the sky. The question of how much the rings weigh sounds like trivia, the kind of number you would skim past in a textbook. It is not trivia. It is the hinge on which the entire history of Saturn turns, and for most of a century, nobody could measure it. You cannot put rings on a scale. You cannot count billions of tumbling ice fragments one by one. The mass of Saturn's rings remained one of those embarrassing blank spaces in planetary science, filled with estimates that disagreed with one another by factors of 10. Many scientists leaned toward heavy rings, and they had a good reason to want them heavy. Heavy rings could be ancient. If the rings held enough material, they could have been formed at the birth of the solar system 4.5 billion years ago and simply endured. Too massive to be seriously depleted even by that constant invisible rain. Heavy rings preserved the comfortable story, the one in the children's drawing in which Saturn has always looked the way it looks tonight. The measurement, when it finally came, arrived by the most delicate method imaginable. In its final months, the Cassini spacecraft repeatedly flew through the narrow gap between the innermost ring and the planet, and while it flew, engineers on Earth tracked the radio tone it broadcast with obsessive precision. Every wisp of gravity tugging on the spacecraft shifted that tone by a whisper, through the same effect that makes an ambulance siren change pitch as it passes you. With the spacecraft threading the space between planet and rings, the two poles could finally be separated. Saturn tugging from one side, the rings tugging faintly from the other. A team led by Luciano Yes unpicked those whispers, and in 2019 they published the first real weight of the rings. It came out to about 15 billion kilograms, a 1 and a 5 followed by 18 zeros. That sounds enormous, and by human standards it is. But planetary scientists heard that number and sat up straight, because it is small, startlingly small. It is about 40% of the mass of Mimas, one of Saturn's smaller moons, a body just under 400 kilometers across. All of it, the entire luminous sprawl stretching most of the way from the Earth to the Moon, the icon, the emblem, the whole crown of the solar system, adds up to less than half of one modest moon. And that lightness has a consequence, because mass is the fuel a ring system burns to stay bright, and Saturn's rings, it turns out, are running on a nearly empty tank. Here is why. The rings live in a dirty neighborhood. That same drizzle of micrometeoroids that helps charge the ring ice also pollutes it. Each tiny impact leaves behind a trace of dark, sooty, rocky material, and over time that soot accumulates, the way fresh snow beside a road slowly greys with passing traffic. The polluting drizzle falls at a rate we can now estimate, because Cassini caught and counted those incoming grains too. So the logic closes like a trap. We know how dirty the rings are, barely dirty at all, still 95% gleaming ice. We know how fast the dirt arrives, and we now know how much ice there is to dilute it. A massive ancient ring could stay bright for billions of years, hiding its age the way a large lake swallows a bag of ink. But a lightweight ring cannot. Fresh snow beside a highway does not stay white for 4 billion years. Run the numbers backward and the conclusion is stark. The rings have been out in that drizzle for something like 10 to 100 million years. Not billions, millions. Let me put that number where it belongs, against the calendar of life on Earth, because this is the fact that rearranges the sky. The solar system is about 4.5 billion years old. If the rings are 100 million years old at the oldest, then for roughly 98% of the solar system's existence, Saturn had no rings at all. When the dinosaurs first walked the Earth, more than 200 million years ago, Saturn was in all likelihood a bare golden ball. A stegosaurus, had it looked up with knowing eyes, would have seen a Saturn that no human being has ever seen, a Saturn without its defining feature, anonymous among the planets. The rings are not older than the mountains. On this evidence, they are younger than the dinosaurs, younger than sharks, younger than trees. The most timeless-looking object in the heavens may be, in the lifetime of the solar system, about as ancient as last week's snowfall. I want you to hold that thought while we go there, just once, in person. close your eyes, and drift with me into the ring plane itself. You're floating among the particles now, and the first thing that strikes you is how quiet the traffic is. A snowball the size of your fist hangs an arm's length away, turning slowly, its surface sparkling where the far, small sun catches it. Beyond it, a boulder the size of a house rotates with the patience of a glacier, and beyond that, thousands more, tens of thousands, dwindling into a bright haze that curves away toward a horizon in both directions until the ring becomes a solid road of light. Above you, blackness. Below you, blackness. The whole shining country you're drifting in is thinner than an office tower is tall, a floor of ice with no ground under it. Everything around you is moving at more than 20 kilometers a second, yet nothing seems to move at all, because everything moves together, the whole nation of ice gliding in formation. It would be the most peaceful place in the solar system, except that now you know what to look for. Watch the smallest grains, the glinting dust between the boulders. Every so often one of them shivers, catches some invisible current, and slips downward, out of the floor of the world, falling toward the striped glowing planet below. Then another, then another. Nothing chases them. Nothing marks their leaving. The road of light simply lets them go, one grain at a time, forever. You're standing inside the countdown, and it makes no sound. Open your eyes. There is one more piece of this story, and it may be the strangest because it offers an answer to the question the young rings force upon us. If the rings were not born with Saturn, where did they come from? What happened, in the astronomically recent past, to wrap the planet in 15 billion kilograms of shattered ice? In 2022, a team led by Jack Wisdom published a scenario that accounts for more of Saturn's oddities at once than anything else on the table. They proposed that Saturn once had one more moon than it has today, a mid-sized icy body they named Chrysalis. For billions of years it orbited quietly among the others. But moons migrate slowly, as tides nudge them, and Chrysalis, in this scenario, was edged into a gravitational argument it could not win, a resonance involving Saturn's own wobbling axis and the distant pull of Neptune. Its orbit went unstable. It swung closer and closer to Saturn, until one pass took it inside the Roche limit, the tidal boundary we met among the rings. And there, the planet's gravity simply took the moon apart. Most of the wreckage spiraled down and vanished into Saturn itself. But a fraction, perhaps 1%, was caught, spread, and ground into the shining disk we now photograph and paint and print on lunchboxes. The same event in their models would have yanked Saturn's axis and left it with the 27-degree tilt it wears today. One catastrophe, two signatures. If that scenario is correct, then say Galileo's sentence again, the one he wrote in bewilderment in 1612, and hear how it lands now. Has Saturn swallowed its own children? Yes. Once, perhaps 100 million years ago, it swallowed a moon nearly whole, and the rings are the crumbs of the meal, and the invisible rain we discovered in the last chapter is the planet still finishing its plate, one grain at a time. The metaphor was never a metaphor, it was a report filed 4 centuries early, and so the countdown runs at both ends. Born, perhaps, 100 million years ago. Draining now at up to tens of thousands of kilograms a second. Projected, by the 2018 analysis, to be substantially gone in something like 100 to 300 million years, with the often quoted middle estimate sitting near 292 million. The exact figure hardly matters. An honest scientist will tell you the rates may vary over time, that rings may even fade and regrow across the ages of a giant planet, that Jupiter, Uranus, and Neptune all keep faint, dark rings that may be the ghosts of brighter ones. What matters is the shape of the truth. Bright rings around Saturn are not a permanent feature of the universe. They are an event, a flash, in the long night of the solar system, and we happen to be alive inside the flash, in the thin sliver of time that contains Galileo, and Huygens, and Voyager, and Cassini, and you, listening tonight. Out of the whole history of the Sun's family, only about 2% of it has Saturn wearing its crown, and every eye that has ever seen those rings, every last one, has been opened during the same brief moment. That is what the calm disk in the eyepiece actually is. It is a countdown that shows no numbers, run by a planet that shows no strain. And everything we know about it, the weight, the rain, the age, the leak inside the gap, every decisive number in the last 2 chapters came from a single machine, a school bus-sized spacecraft that spent 13 years circling Saturn and ended its life by design in Saturn's own sky. Before we climb to the North Pole and confront the shape waiting there, you should meet the machine properly, because the story of how we learned all of this is also the story of what it cost. Every fact in this video has a source, and the remarkable thing is how many of them share the same one: the weight of the rings, the taste of the falling ice, the storms we have yet to meet, the strange field we have yet to measure, the shape at the pole we have yet to visit. Again and again tonight, when we ask how humanity knows something about Saturn, the answer will be a single name: Cassini. Knowledge does not simply arrive. It has to be collected by something from somewhere, and for 13 years the somewhere was Saturn, and the something was a robot the size of a school bus, hanging in the black 1.5 billion kilometers from the people who built it. If tonight has a second main character besides the planet itself, this is it, and its story deserves telling properly, because the ending is coming, and the ending is not gentle. The machine left Earth on October 15th, 1997, folded on top of a rocket, carrying the hopes of 3 space agencies and the better part of 2 decades of planning. Cassini was among the largest and most sophisticated interplanetary spacecraft ever built, nearly 7 meters tall, with a launch mass over 5,500 kilograms once its fuel was loaded. Most of that fuel, because getting into orbit around a distant giant requires carrying your brakes with you. Sunlight at Saturn is only 1% of what it is here, far too weak for solar panels of any reasonable size, so Cassini carried its own hearth, a generator warmed by the slow decay of plutonium, a design decision that would, years later, shape the manner of its death. Bolted to its side rode a passenger, a lens-shaped probe named Huygens, built by the European Space Agency for a separate and audacious errand we will come to shortly. No rocket on Earth could throw all of that mass straight to Saturn. So Cassini spent its first 7 years doing something that still sounds like a magic trick. It fell around the solar system, borrowing speed from the planets themselves, swinging close past Venus, then Venus again, then Earth, then Jupiter, each flyby slinging it faster, each world donating a little of its own orbital energy to the cause. 7 years of patient falling, 3.5 billion kilometers of accumulated road, before the destination even began to grow large in the cameras. Then came the night that decided everything. On the 1st of July 2004, Cassini arrived, and arrival was not a matter of drifting in gently. The spacecraft came in fast, crossed the ring plane through a gap between the faint outer rings, then turned its engine forward and burned for 96 agonizing minutes to slow itself enough for Saturn's gravity to catch it. During part of that maneuver it passed closer to the rings than it ever would again for a decade, and its cameras, almost in passing, returned images of the ring structure sharper than anything in history. Lanes and grooves and ripples resolved for the first time as the machine threaded its way in. One burn, executed alone, 80 light minutes from any helping hand. Had the engine failed, Cassini would have sailed past Saturn and out into the dark, $1 billion monument to almost. The engine did not fail. The spacecraft slipped into orbit, and for the first time in human history, Saturn had a permanent companion built by human hands. 6 months later, Cassini released its passenger, and the passenger did something that has still never been repeated. On January 14th, 2005, the Huygens probe fell into the orange haze of Titan, Saturn's largest moon, a world bigger than the planet Mercury, and parachuted for 2.5 hours down through an atmosphere denser than Earth's, and landed and kept transmitting. It photographed river channels carved by liquid methane. It came to rest on a floodplain strewn with rounded pebbles of water ice, frozen harder than granite. It remains to this day the most distant landing humanity has ever performed, and though Titan is a story for another night, note what it establishes. This mission did not go to Saturn to take postcards, it went to touch things. And then Cassini settled into the long work, and the long work is the part that matters most for our purposes tonight. 13 years. By the end of them, the odometer would read 7.9 billion kilometers, a distance so long that light itself needs more than 7 hours to cross it, logged by a machine that was never once touched by a human hand after the day it left the ground. Thousands of people across more than 24 countries kept it flying, engineers and navigators and scientists who checked its temperature and listened for its voice every single day for 2 decades, many of them spending the whole middle of their careers, and some of them nearly all of it, on this one spacecraft. 294 orbits of Saturn, each one redesigned and renegotiated by navigators playing billiards with the gravity of Titan, using flyby after flyby to bend the spacecraft's path, tilting it high over the poles, dropping it flat along the ring plane, stretching it out toward distant moons and reeling it back in. Nearly 500,000 photographs, flights through the ice geysers of Enceladus, tasting salt water from an alien ocean, and above all, time. That is the resource no flyby can gather. Voyager saw Saturn for a few intense days on its way to somewhere else. Cassini stayed. It watched a world where a single season lasts 7 years, and it stayed long enough to watch the seasons actually change, winter light creeping onto the North Pole, summer draining out of the south. It watched a 30-year storm cycle fire its once-in-a-generation eruption, and was on hand for every hour of it. It watched colours shift, clouds migrate, radio rhythms drift out of tune with themselves. Every claim in this video that includes the word decades, every sentence that says the hexagon has not changed, or the rings are draining steadily, or the seasons did this, stands on those 13 patient years. Without a witness who stays, a planet like Saturn can hide anything. The mission's whole design was a refusal to look away. But staying has a price, and the price compounds quietly. Every orbit correction, every tilt of the trajectory, every Titan rendezvous spent a little of the propellant Cassini had carried from Earth, and no ship was coming to refill the tank. By 2017, after 2 decades of flight, the gauge was approaching empty, and an empty tank created a problem that was not about the spacecraft at all. It was about what the spacecraft had discovered. Cassini itself had found the water plumes of Enceladus and the evidence of a warm, salty global ocean beneath that moon's ice, one of the most promising places in the solar system to look for life beyond Earth. A dead, unsteerable Cassini, tumbling around Saturn for centuries, would eventually hit something, and the mathematics of chance said that something could be Enceladus or Titan. The spacecraft was not sterile. It carried Earth microbes, dormant but perhaps not dead, and a store of plutonium. The mission's guardians faced the question every parent of a machine dreads, and they answered it the only responsible way. While there was still fuel enough to steer, Cassini would be steered deliberately into Saturn itself, where the planet's own atmosphere would tear it apart and sterilize every fragment. The witness would be burned to protect the worlds it had discovered. That decision, made while the machine was still healthy, still returning flawless data every day, hangs over everything that follows tonight. But it also opened one final door, because a spacecraft with a death sentence can be sent places no one would ever risk a healthy one. Between the orbit of the innermost ring and the cloud tops of Saturn lies a gap about 2,000 kilometers wide, where nothing built by humans had ever flown. In its last 5 months, Cassini was aimed through that gap 22 times, and it was in those dives, called the grand finale, that it weighed the rings by radio whisper, and tasted the equatorial rain of ice and organics, and measured, closer than ever before, the magnetic field whose secret we will confront later tonight. The mission saved its most dangerous, most valuable science for the road to its own funeral. We will be in the room for the end before this video is over. I promise you that. The final morning, the last signal, and what it felt like for the people who had given 20 years of their lives to one machine, all of that is coming in a later chapter, where it belongs, at the end of the evidence it paid for. For now, the witness is in position, healthy, cameras on, circling a giant with 7-year seasons, and we can return to the planet with a new kind of confidence. From here on, when I tell you something about Saturn, you will know where it came from. You will know who was watching, and for how long, and what it eventually cost. So let us use the witness. Let us climb with it, up out of the ring plane, up over the golden bands to the very top of the world. Because in 1981, a spacecraft moving too fast to stop caught something at Saturn's North Pole in the corner of its eye. Something so unlikely that scientists spent years making sure it was real. Cassini's job was to go back and look at it properly. What it confirmed is still there tonight, turning slowly in the polar dark, and it is the single strangest shape in the solar system. In November of 1980, a spacecraft the size of a small car swept past Saturn at more than 50,000 kilometers per hour, cameras firing, with no ability to slow down and no intention of coming back. Voyager 1 was on its way to Titan and then out of the solar system forever, and Saturn got only a few frantic days of its attention. 9 months later, in August of 1981, its twin, Voyager 2, made its own pass and continued on toward Uranus. Between them, the two spacecraft returned tens of thousands of images, humanity's first close portraits of the ringed planet, and among those images, almost incidentally, were frames looking down toward the North Pole. The pole was sliding into its 7-year winter, lit at a low, raking angle, difficult to photograph and easy to ignore. The images went into the archive with all the others, and the Voyagers flew on, and for 7 years nobody noticed what they had caught. Pause on a question that sounds trivial and is not. Why did humanity have to wait for a passing spacecraft to see the top of Saturn at all? Astronomers had been studying this planet through telescopes for 3.5 centuries by then. The answer is a quiet accident of geometry that fits tonight's theme almost too well. From Earth, we view Saturn nearly edge-on. The planet's tilt means we sometimes peek a little over its shoulder, but we never ever see its poles face on, the way you would look down at the top of a globe. For 350 years, every telescope ever aimed at Saturn saw the rings, the bands, the golden middle of the world, while the poles stayed permanently foreshortened at the edge of view, hidden in plain sight. Whatever sat on top of Saturn was invisible from Earth, not because it was small, but because of where we happened to stand. The only way to see the crown of the planet was to physically travel there and look down. So when the Voyager's archive finally held the first true downward views, it held images of a place no human eye in all of history had ever properly seen. Then, in 1988, an atmospheric scientist named David Godfrey did something patient and unglamorous. He gathered the Voyager frames of Saturn's North Polar region and stitched them together, aligning them, correcting them, building a single composite view looking straight down at the top of the planet, the perspective no single photograph had captured. And when the mosaic came together, there it was. Circling the pole at about 76 degrees north latitude, the clouds were not arranged in a circle, they were arranged in a hexagon, 6 straight sides, 6 distinct corners, a geometric figure drawn in wind sitting on top of a gas giant. You should understand how a scientist reacts to something like that, because the reaction is not delight, it is suspicion. A hexagon is what you get from an error. It is what appears when the frames of a mosaic are misaligned, when a processing algorithm clips a boundary, when an instrument leaves its own signature stamped on the data. Something with straight edges and sharp corners, on a planet made entirely of flowing gas, reads as an artifact of the camera, not a feature of the world, for the simple reason that nature at planetary scale is not supposed to draw with a ruler. Storms are round, jets are wavy. Turbulence is turbulence. Godfrey checked and checked again, and the hexagon survived every check. It was moving with the planet, not with the camera. It was there in frame after frame from different angles at different times. The straight edges were real. The corners were real. Saturn's North Pole was wearing a geometric crown, and no one had the faintest idea why. Let me give you its true dimensions, because the shape alone does not convey what this thing is. Each of the 6 sides is roughly 14,500 kilometers long. Side to side, the hexagon spans about 30,000 kilometers. The Earth, for comparison, is about 12,700 kilometers across. You could set 2 entire Earths side by side inside the hexagon and still have room left over. This is not a cloud feature in the sense you might picture, some pattern you would need instruments to detect. It is a structure more than twice the width of our planet, plainly visible in any decent image looking down at the pole, as obvious as a stop sign painted on top of the world. And it is not a painting. It is a jet stream, a river of wind, the same kind of high-altitude current that steers weather across the Earth, except that this one blows at more than 300 kilometers per hour, and, instead of meandering the way every jet stream on Earth meanders, it turns 6 sharp corners and closes back on itself in a near-perfect polygon. The whole figure rotates, and here is an early clue worth filing away. It rotates in about 10 hours and 39 minutes, which matched at the time the best guess for the rotation of Saturn's own interior, the spin of the planet's unseen body far beneath the clouds. Storms drift, weather wanders. The hexagon does neither. It turns with the planet rigidly, all 6 corners moving together like the painted figures on a carousel, as if the shape were bolted to something far below. Now, an honest skeptic hearing all this has one very reasonable refuge left. The Voyagers saw the pole for a few days in 1980 and 81. Weather is weather. Perhaps the hexagon was a passing arrangement, a coincidence of currents that happened to hold for a season and then dissolved. Earth's atmosphere occasionally produces short-lived geometric patterns, hexagonal cells in cooling cloud layers, straight-edged fronts. Give it a year, surely, and the sharp corners would soften, the sides would buckle, and Saturn would go back to looking like a proper planet. That is the sensible prediction. That is what wind does. 23 years after Voyager, Cassini arrived and pointed its instruments at the North Pole, and the sensible prediction died. The hexagon was still there, the same shape, the same 6 sides, the same latitude, 76 degrees north, the same size within the limits of measurement. Not a similar hexagon, not a descendant, but by every indication the very same structure, still turning as if the 23 intervening years, an entire human generation, had been a single afternoon. And because the pole was deep in its 7-year winter when Cassini arrived, the spacecraft could not even see it in ordinary light at first. It found the hexagon in the dark, by its own heat, imaging in the infrared, the shape glowing warm against the colder clouds, sharp-cornered even in thermal light, turning patiently through the polar night with no sun to drive it. When sunlight finally crept back over the pole after the equinox of August 2009, the cameras confirmed in visible light what the heat maps had been saying all along. Nothing had changed. Through an entire Saturnian winter, through darkness that lasted longer than most wars, the hexagon had held its shape without an audience. I want you to experience this thing just once, the way no camera ever has. Come down with me, in your mind, out of black space, toward the top of Saturn. The pole grows beneath you, a dim golden plain of cloud, streaked and marbled, soft in every direction. You level off high above the cloud deck and fly toward the pole, and ahead of you, out of the haze, a boundary rises. It is a wall of cloud, sharper than any coastline, running from horizon to horizon perfectly straight. You turn and follow it. At the speed of an airliner, you would follow this one wall for 18 hours, and it would not bend, not once. A line ruled across the top of a world, cloud on one side, different cloud on the other, as if 2 kinds of sky had signed a border agreement. And then, far ahead, you see it coming. The corner. The wall simply turns, cleanly, through a wide, deliberate angle, and sets off in a new direction, just as straight as before. You bank and follow it around. There is no debris at the corner, no chaos, no churn of collision. The turn is smooth, silent, and colossal. A bend in the sky executed with the composure of a machined part, and it has been executing that same turn in that same place since before you were born. Hanging there, watching a piece of geometry 2 Earths wide rotate beneath you like the world's calmest gear, you understand why people who study this planet for a living still lower their voices slightly when the hexagon comes up. Because the comparison to everything else we know is not close. On Earth, a powerful hurricane holds together for perhaps 2 weeks before it dies. The greatest storm we have ever known anywhere, Jupiter's Great Red Spot, has persisted for at least 2 centuries, and it is famous precisely because it lasts. But look at it honestly, and it is a thing in visible decline, an oval that has been shrinking for 100 years, from roughly 40,000 kilometers across in the 1800s to around 14,000 today, wobbling, shedding streamers, changing color year by year. It endures, but it ages. The hexagon does not appear to age. Between 1981 and today, across more than 40 years of intermittent and then continuous observation, no instrument has measured any clear change in its size, its shape, its latitude, or its character. Every other storm we know is a candle burning down. This is a shape that simply persists, indifferent to seasons, indifferent to sunlight, indifferent to time, and 40 years is only how long we have been watching. It is a minimum, not an age. For all we know, the hexagon predates the telescope. For all we know, it predates the rings. One more detail before we go deeper, because the hexagon is not empty. It is a frame, and the frame has a portrait inside. At the exact center, on the pole itself, sits a separate storm, a compact cyclone with a clear, unblinking eye some 50 times wider than the eye of a terrestrial hurricane, walled by clouds racing at more than 500 kilometers per hour. A monster in its own right, squatting in the middle of the geometry like a spider at the center of a 6-sided web. If that cyclone existed on Earth, it would span an entire continent, and its eye alone would swallow whole countries. Any other planet would lead with it as the main attraction, put it on the cover of the textbook, name it the way we named Jupiter's spot. At Saturn's north pole, it is the afterthought, a continent-sized whirlpool reduced to a decoration because the thing framing it is stranger than it is. So here is where the evidence has carried us. A jet stream that draws straight lines, corners that hold for 4 decades, a rotation locked to the hidden body of the planet, a structure that outlasted winter, outlasted its discoverers' careers, and shows no sign it ever intends to stop. And everything I have told you so far is only the view from above, the flat picture, the pattern as it appears on the surface of the clouds. It was Cassini, staying on watch year after year, that discovered the truth the flat picture concealed. The hexagon is not a pattern on Saturn. It is a structure in Saturn, and it goes down. The picture you probably have in your mind right now is a flat one, a pattern lying on top of the clouds, the way frost lies on a window, a 2-dimensional figure decorating the surface of the planet. That is how every image presents it, because images are flat. It is also completely wrong, and discovering how wrong it was took a spacecraft that could stare at the same spot for years, with instruments that see heat as well as light. When Cassini measured temperatures through the hexagon's cloud walls, tracing the winds at level after level below the visible deck, it found that the 6-sided jet does not fade away beneath the surface. It keeps going. Down through the ammonia clouds, down through layers no camera can penetrate, the hexagonal wind pattern continues for at least 300 kilometers below what we see, and analyses of Saturn's gravity and wind structure suggest the jet's roots may reach enormously deeper, perhaps thousands of kilometers, into the body of the planet. Let the flat picture go then, and replace it with the true one. The hexagon is not a pattern on Saturn. It is a tower, a rotating prism of wind, 6 walls of moving air, extending from far down inside the atmosphere up to the cloud tops, the way a mountain extends from the seafloor to its peak. What the photographs show, the crisp geometric outline that made the shape famous, is only the summit. The structure itself is buried in the planet, anchored somewhere we cannot see, in that hidden interior whose spin the hexagon so faithfully follows. Suddenly, the rigid rotation makes a terrible kind of sense. The shape turns with the body of Saturn because the shape is, in some real sense, part of the body of Saturn, a piece of the deep planet expressed in weather. And then, in the last years of the mission, Cassini found the detail that moves this from remarkable to genuinely eerie. As the North Pole tilted into spring and then summer, sunlight returned to latitudes that had spent years in darkness, and the upper atmosphere above the pole began to warm and stir. High in the stratosphere, hundreds of kilometers above the cloud-level hexagon, a seasonal vortex began to spin up, a warm polar swirl of the kind models predicted. Lee Fletcher and his colleagues watched it form in the thermal data, and in 2018 they published what they saw. The new vortex growing in a different layer of the atmosphere, out of different air driven by seasonal heating that the deep hexagon does not feel, came out hexagonal. Same 6-sided shape, same orientation. A second hexagon, stacked directly above the first, like a story added to a building, floors apart yet built to the same blueprint. The pattern had reached upward, imprinting itself on a layer of atmosphere that by every conventional expectation should have swirled into an ordinary circle. Whatever the hexagon is, it is not confined to its own level of the sky. It propagates. It reproduces its geometry in air far above its walls, as if the shape itself were contagious. The same seasons that built the second hexagon revealed something else, this time in plain colour. When Cassini photographed the interior of the hexagon in 2012, the region inside the walls was a soft, deep blue, a startling pool of cool colour on a golden planet. By 2016, the same region had turned warm gold. The colour of a storm the size of 2 Earths changed, completely, in 4 years. The explanation is chemistry, and it is elegant. During the long polar winter, with no sunlight to drive reactions, the air inside the hexagon ran clear of haze, and clear, deep atmospheres scatter blue light. For the same reason Earth's sky is blue. When the sun returned, its ultraviolet light began cooking methane in the upper air into a photochemical smog of fine particles, and the pool inside the walls slowly filled with golden haze. But notice what that story quietly requires. The inside of the hexagon and the outside of the hexagon kept different chemical inventories for years, while sitting a wall's width apart in the same atmosphere. The winds of the hexagon are a fence. Air inside stays inside, air outside stays outside. The barrier is real enough to paint itself in two colours, sharp enough to hold a boundary between two skies, and it held that boundary for the entire time we were watching. So can physics explain any of this? The honest answer, and I want to give it to you carefully, is yes, partly, and the partly is where the mystery actually lives. Here is what we can explain. In 2010, researchers at the University of Oxford ran an experiment of almost childlike simplicity. They mounted a cylindrical tank of water on a rotating table, spun it up, and used a small ring spinning at a different speed to create a sharp velocity difference in the fluid, a miniature jet stream. Then they watched, and in run after run the smooth circular jet buckled, kinked and settled into stable polygons that rotated with the tank. Triangles at some settings, squares and pentagons at others, and at settings whose proportions resemble Saturn's, hexagons. Ordinary water, on an ordinary table in England, spontaneously drawing the same figure that crowns a gas giant. No machinery in the fluid, no template, no trick. The phenomenon is called a barotropic instability, and it appears in computer simulations of Saturn's polar jet as well, and even, fleetingly, here at home. Powerful hurricanes on Earth sometimes develop polygonal eye walls for a few hours, 5, 6, 7-sided figures turning inside the storm, and cloud patterns over Earth's own poles occasionally sketch brief geometric shapes. When a fast jet shears against slower air at just the right ratio, waves form along the boundary, and a wave that fits around the circle a whole number of times can lock into place, and 6 is simply a number the mathematics is happy to choose. A hexagon, it turns out, is not an outrage against nature. It is one of nature's available shapes. If that were the whole story, the hexagon would be a solved problem, a pretty demonstration for fluid dynamics courses, and this part of the video would not exist. But look at what the tank experiment actually reproduces, and what it does not. The tank makes hexagons that last for minutes, in water a few centimetres over a rigid floor, in a laboratory where every condition is controlled and constant. Saturn's hexagon has persisted, unchanged for more than 40 years, through seasonal forcing that reshapes the rest of the polar atmosphere, on a planet with no floor at all. The tank cannot tell us why the pattern reaches down toward the planet's interior, or how it stamped a copy of itself into the stratosphere above. The models can produce polygons, but coaxing them to produce this polygon, with its exact size, its speed, its rigidity, its indifference to time, requires tuning that begins to feel less like explanation and more like curve fitting. And there is a number the models keep failing to justify cleanly. Why 6? Change the assumed depth or sharpness of the jet, and simulations happily produce pentagons, heptagons, wavy circles. Nature, offered the same menu at Saturn's North Pole, chose 6, and has never once changed its order. There is a version of this story in which the order does change, and it is worth pausing on, because it sharpens what stability actually means here. In some simulations, a polygonal jet is not locked to one shape forever. Nudge the forcing, alter the sharpness of the winds, and the pattern can in principle reorganize, a hexagon relaxing into a pentagon buckling into a square, the figure stepping down through the geometry like a guitar string changing notes, which means the hexagon is not necessarily eternal even in theory. It could, on some future morning of some future year, simply be something else when we look. Astronomers have now watched it through more than one complete cycle of Saturn's seasons, through the full swing from northern winter to northern summer and back, through the years-long crescendo of solar heating that rebuilt the stratosphere above it and repainted the air inside it. Those are exactly the kinds of nudges that reshape patterns. The note has never changed. 40 years of forcing, and the string still plays 6. Every year that passes without so much as a flutter makes the shape's composure a little harder to wave away, and makes the quiet question underneath it a little louder. What, exactly, is holding it? Sit with that image for a moment, gently, because it deserves a slow thought before we move on. Somewhere above you tonight, over the top of a planet you could find with a cheap telescope, a 6-sided wall of wind 2 Earths wide is turning in the dark, holding a note it has held since before most of the people alive today were born. And then there is the fact that, for my money, is the single most quietly disturbing thing about the entire phenomenon. Saturn has 2 poles. The South Pole has its own powerful polar jet, its own colossal cyclone sitting on the pole itself, photographed by Cassini in 2006 with a clear eye and eye-wall clouds towering tens of kilometres, a storm that would dwarf anything Earth has ever produced. The two ends of the planet share the same atmosphere, the same rotation, the same chemistry, the same physics, and to a first approximation the same conditions. If the hexagon is just fluid dynamics doing what fluid dynamics does, the South Pole is an obvious place for it to do it again. There is no hexagon at the South Pole. There is no pentagon, no square, no geometry of any kind. The southern storm is round as every storm on every other world we have ever observed. One planet, two identical poles, and the mathematics chose to draw its figure on exactly one of them, and we do not know why. Nothing in the accepted explanation forbids a southern hexagon. It simply is not there. So file the hexagon precisely, because precision is what this planet demands. It is not unexplained. It is worse than unexplained. It is half explained, a shape we can conjure in a bucket of water, but cannot account for on the world where it actually spins. A storm that ignores time on a planet whose whole performance, as we keep discovering, is the appearance of calm. The walls hold, the corners hold, the copy above it holds, and the deeper you look beneath those walls, the less familiar Saturn becomes, because the strangeness we have met so far, falling rings and geometric storms, is at least strangeness you can photograph. The next anomaly cannot be photographed at all. To find it, we have to leave the world of images entirely and follow Cassini's instruments down into the invisible, where Saturn is hiding the single most impossible thing about it. Let us step back for a moment and put the pieces on the table, because we have gathered more than it may feel like, and the shape they make together matters. We began with an icon, the serene ringed planet, and we have now caught it in two acts of quiet deception. The rings, the very symbol of permanence, turned out to be a young temporary structure, draining into the planet through an invisible rain, most likely the wreckage of a moon the planet destroyed, on a countdown no photograph reveals. The North Pole, which should be crowned by ordinary swirling weather, instead carries a six-sided tower of wind that ignores time, half explained at best, duplicated in the sky above itself, absent from the identical pole in the south, a dying crown and an impossible one. Two exhibits, both hidden behind the same calm golden face. Now for the third exhibit, and this one is about the face itself, because the blandest thing about Saturn, its smooth, muted, almost featureless appearance, turns out to be the biggest lie of all. Put Saturn next to Jupiter in your mind. Jupiter is the solar system's drama student. Its face is a riot of belts and swirls, red and white and brown, storms visibly churning, everything declared right on the surface for any backyard telescope to see. Saturn, by comparison, looks sedated. Softer bands, gentler colours, a face like still water under a honey-coloured fog. Generations of observers concluded the obvious. Jupiter is the violent giant, Saturn the gentle one. But the softness is not gentleness. It is concealment in the most literal physical sense. Saturn is colder than Jupiter, and its atmosphere is deeper and taller, so a thick blanket of high-altitude haze hangs over the entire planet, washing out the contrast of everything beneath it. The weather is there, all of it, Jupiter-grade and worse. It is simply happening behind a veil. Saturn does not lack Jupiter's chaos. It curtains it. Here is what the curtain is hiding. Wrapped around Saturn's equator blows a jet of wind that reaches roughly 1,800 kilometers per hour. I need to put that number next to something human, because on its own, it refuses to mean anything. The fastest wind gust ever measured on the surface of the Earth during a tropical cyclone in Australia in 1996 was 408 kilometers per hour, and it lasted seconds. The most violent tornadoes on our planet briefly touch perhaps 480. Saturn's equatorial jet blows at 4 times the strongest gust our world has ever managed, not in gusts, but continuously, for as long as we have been able to measure it decade after decade without pause. And it does this on a world where, remember, there is no ground. Nothing on Saturn ever makes landfall. On Earth, every storm is in a losing negotiation with the surface. Mountains shred hurricanes. Continents starve them. Friction with land and sea bleeds their energy away, which is why even the worst of our storms die in weeks. Saturn's winds have never touched anything solid in the entire history of the planet. There is no coast to wreck them, no mountain to break them, no floor to slow them down. They simply blow forever, through a world that is nothing but sky. I want you to feel what that means, so come with me one last time into the planet itself, because this is the descent with no floor. You fall feet first through the top of Saturn's atmosphere, through air so cold it would freeze the breath in your chest, minus 180 degrees, thin and golden with haze. The fog thickens as you drop, and then the first cloud decks swallow you. Pale ammonia ice, whipped sideways by winds you cannot see, but can feel as a pressure that never lets up, faster than any wind that has ever blown on Earth, carrying you around the planet as you fall. You keep falling. The light dims from gold to bronze to a deep brown dusk, and somewhere far below the visible clouds you pass through decks of ammonium compounds, and deeper still, incredibly, clouds of ordinary water, an ocean's worth of it, suspended in darkness where no sunlight has ever reached. You keep falling. The air thickens around you until it presses like deep seawater, and it grows warm, then hot, heated not by the faraway sun but by the planet itself beneath you. You are waiting for the landing, braced for it, and it never comes. There is no surface anywhere below you. The gas simply grows denser and hotter, hour after hour of falling, until the air around you is no longer quite air but a glowing fluid, and thousands of kilometers down that fluid thickens into an ocean of liquid hydrogen, and deeper still, under pressures, millions of times what your body was built for, the hydrogen itself is crushed into something that shines like molten metal. You do not land on Saturn, you dissolve into it. Somewhere in that bottomless descent, everything that fell stops being a thing that fell and becomes simply more Saturn. That is what is under the calm golden face. Not a world with a flaw, a fall that never ends, wrapped in winds that never stop. And every 30 years or so, the curtain rips. This is the part of Saturn's biography that almost nobody knows, and it deserves to be famous. Roughly once per Saturn year, once every 29 to 30 Earth years, the planet erupts. A brilliant white storm punches up through the haze veil, so large and so bright that astronomers in the 1800s could see it from Earth with the telescopes of the day. They called these events Great White Spots, and the record of them reads like a pulse. 1876, 1903, 1933, 1960, 1990. A planet-sized heartbeat, striking about once a generation, as if Saturn spends 3 decades swallowing its own violence, and then, for a few months, simply cannot anymore. In December of 2010, the pulse struck again, and this time, for the first time in history, there was a witness in orbit. Cassini watched the entire event from a front-row seat, and what it recorded remains one of the most violent meteorological events ever documented on any world. The storm began as a single bright spot in the northern hemisphere, a white welt of cloud boiling up from the water layers far below, dredging material from perhaps 160 kilometers beneath the cloud tops. Within weeks, the head of the storm had grown larger than the entire Earth, and then it began to spread sideways, unrolling downwind day after day, a tail of churning white clouds stretching east around the planet. Within about 6 months, the tail had wrapped around the whole of Saturn, a storm more than 300,000 kilometers long, a weather system that had encircled its own world and whose head, still raging, was now advancing on its own tail. Inside it, Cassini's instruments counted lightning, and the counting is worth a slow sentence. At the storm's peak, Saturn was discharging lightning more than 10 times per second, and the radio crackle of those bolts registered up to 10,000 times more powerful than the signature of terrestrial lightning. Not 10 times, 10,000! Flashes powerful enough that Cassini could image them lighting the clouds from inside on the day side of the planet. The storm even reached into layers where storms are not supposed to matter. High above the cloud deck in the thin stratosphere, the eruption injected a colossal bubble of hot air, and as Cassini and ground-based telescopes tracked it, that invisible beacon warmed by roughly 80 degrees, the largest stratospheric temperature spike ever measured on any planet, accompanied by a surge of ethylene gas 100 times beyond anything the chemical models predicted. Nobody foresaw that. Nobody's model of Saturn contained it. And when the storm finally died, in the middle of 2011, it died in the most fitting way imaginable. The head, having circled the entire planet, ran into the cold wreckage of its own tail and choked on it. Saturn's greatest storm was not stopped by any obstacle in its way. There are no obstacles. It was stopped by itself, the only opponent on the planet in its own weight class. And then the haze closed over, the band smoothed out, and within a couple of years the face of Saturn was calm honey and still water again, as if nothing had ever happened. The veil does not just hide the violence, it erases the evidence afterward. One more entry for this exhibit, and it is the strangest, because it connects the violence back to everything else we have found tonight. The very top of Saturn's atmosphere, the thin outer fringe called the thermosphere, is hundreds of degrees hotter than it has any right to be. Sunlight at 9.5 astronomical units is far too weak to heat it to the temperatures we measure, by an enormous margin, and this failure of the books to balance, which afflicts all 4 giant planets, has been called the energy crisis of the outer solar system. At Saturn, Cassini's final data traced at least part of the missing heat to electric currents pouring in along the planet's magnetism from its auroras, and some researchers suspect an additional culprit, one you already know. The constant invisible rain of charged ring material sliding down the field lines into the upper air may itself be helping to heat the fringe of the atmosphere. Think about what that would mean. Even Saturn's fever traces back in part to the slow devouring of its own rings. The exhibits are not separate. The dying crown, the hidden violence, the too hot sky, they thread into one another, parts of a single system whose organizing principle seems to be that nothing true about this planet is visible from the outside. Which brings us to the door of the final anomaly, the deepest one, and I have saved it for now because it is not weather and it is not ice. It is written into the planet's fundamental machinery, in a property most people never think about at all, and it is the closest thing tonight to a genuine impossibility. To see it, we need to talk about what makes a planet magnetic, and about a rule, almost a century old, that Saturn appears to be breaking. Every compass on Earth is pointing at a lie, and the lie is one of the healthiest things about our planet. Walk outside with a compass, and it will point north, but not at true north, not at the spot where Earth's rotation axis meets the surface. It points at the magnetic pole, which currently sits hundreds of kilometers away from the true pole out in the Arctic, and which refuses to stay put, wandering tens of kilometers per year. Sailors have known about this mismatch for 6 centuries. Every navigator who ever crossed an ocean by compass had to correct for it, adding or subtracting the local error, because Earth's magnetic field is tilted with respect to its spin. The tilt is about 11 degrees. Our planet's magnetism leans, wobbles, drifts, and occasionally over geological time collapses and flips north for south entirely. And here is the crucial point, the one this whole chapter turns on. That messiness is not a defect. That messiness is the signature of the machine that keeps you alive. The machine is called a dynamo. Deep beneath your feet, Earth's outer core is an ocean of molten iron, 3,000 kilometers down, churning with slow convection as heat escapes the planet's heart. Molten iron conducts electricity, and when a conducting fluid moves through a magnetic field, it generates electric currents, and those currents generate more magnetic field. The motion feeds the field, and the field threads the motion, a loop that has sustained itself inside the Earth for billions of years, throwing a protective cage of magnetism around the planet that deflects the solar wind and shields the air you're breathing right now. But the churning is turbulent. It is weather in molten metal. And so the field it produces is lumpy, tilted, restless, imperfect, in exactly the way a flame flickers and a river swirls. Physicists do not merely observe this messiness, they expect it. The turbulence is what regenerates the field. In a very real sense, the imperfection is the engine. Look around the solar system, and you see the same signature everywhere. Jupiter's enormous field is tilted about 10 degrees from its spin axis, close to Earth's lean. Uranus is tilted 59 degrees, and its field is not even centered in the planet. Neptune leans 47 degrees, similarly off-center, a dynamo in apparent disarray. Mercury's small field is offset northward. Everywhere we have flown a magnetometer, we have found fields that lean and wander, each one a fingerprint of the turbulent metal weather inside its world. By the time spacecraft reached the outer planets, this was as close to a law as planetary science gets. Dynamos are messy. Show me a planetary magnetic field, and I will show you a tilt. Then we measured Saturn properly, and Saturn broke the law. The first hints came from the flyby era, when spacecraft magnetometers found Saturn's field surprisingly well aligned with its rotation. But flybys are glances, and the definitive measurement had to wait for the end of everything. In those final months of 2017, when Cassini was diving through the gap inside the rings, it was passing closer to the body of Saturn than any instrument had ever been, and its magnetometer, run by a team under Michel Doherty, was finally close enough to map the field's true geometry. The team expected at last to resolve the tilt, the lean that every dynamo must have. They found none. Dive after dive, the data came back the same. To the precision of the instrument, the magnetic axis of Saturn and the rotation axis of Saturn are the same line. The measured tilt is less than 1/100th of a single degree. Earth leans 11 degrees, Jupiter leans 10, Neptune leans 47. Saturn leans, at most, 0.01 and possibly less, because at that level, the measurement runs out of precision before the tilt runs out of smallness. Let me try to make that number physical. Take a hair from your head and carry it to the far end of a football field. The width of that hair, seen from the other end zone, covers about 1/100th of a degree. That is the most lean that Saturn's entire planetary magnetic field, a structure larger than the planet itself, is permitted by the data. It is not approximately aligned. It is aligned to the edge of our ability to detect misalignment at all. You might think, so what? A tidy planet. Surely somewhere in the solar system's variety there is room for one dynamo that runs clean. This is where the story stops being a curiosity and becomes a confrontation with a theorem, and the theorem is almost a century old. In 1933, an English astrophysicist named Thomas Cowling proved a result so durable that it carries his name to this day. Cowling's theorem says, in essence, that a perfectly axisymmetric magnetic field, a field with flawless rotational symmetry about its axis, cannot be maintained by a dynamo. The mathematics is technical, but the heart of it can be said plainly. A dynamo keeps its field alive by folding and stretching and twisting the field lines through the motion of the fluid, and that regenerative folding has no purchase on a field that is perfectly smooth around its axis. Perfect symmetry gives the dynamo nothing to grip. A field like that, the theorem says, must decay. It cannot sustain itself. In other words, physics does not merely fail to predict a perfectly aligned, perfectly symmetric planetary field. Physics forbids one as a self-sustaining object, and it has forbidden one since 1933, since before anyone had flown a magnetometer anywhere. Now hold the two facts next to each other, because this is the collision at the centre of tonight. Theory, resting on 90 years of mathematics, says a dynamo's field cannot be perfectly symmetric. Measurement, resting on the closest passes ever flown, says Saturn's field is symmetric to better than 1 part in 1,000 of Earth's lean, with no detected departure at all. Something has to give, and it is not the theorem, whose logic is sound, and it does not appear to be the data, which are among the cleanest Cassini ever returned. What gives, almost certainly, is the assumption hiding in between. The assumption that what we measure outside the planet is what the dynamo is actually doing inside it. And so, we arrive at the accepted escape route, the hypothesis most experts now lean on, and I want you to hear it clearly, because it may be the most quietly unsettling idea in this entire video. The proposal is that Saturn's dynamo is just as messy as Earth's, just as tilted, just as turbulent, exactly as the theorem requires. We simply are not allowed to see it. Between the deep dynamo and the outside universe, the theory goes, lies a concealing layer, and Saturn built it out of rain. Not water rain this time, helium. Deep inside Saturn, at pressures and temperatures our laboratories can barely brush against, helium stops dissolving in liquid metallic hydrogen, the way oil separates from water. It gathers into droplets, and the droplets are heavier than the hydrogen around them, so they fall, a rain of liquid helium descending for thousands of kilometers toward the core, releasing heat as it goes. That falling rain does two things. First, it explains a fact you already know from earlier tonight, that Saturn radiates roughly twice the energy it receives from the Sun. The helium rain is part of the furnace. Second, and this is the key, the region it falls through becomes layered, stratified, stable, a zone of conducting fluid that does not convect, does not churn, just turns smoothly with the planet, wrapped around the true dynamo like a shell. Think of that shell as frosted glass around a fire. Inside it, the real field is presumably doing what all dynamo fields do, leaning, lurching, knotting itself, flickering with the turbulence that keeps it alive. But as the field reaches outward through the smoothly rotating shell, the shell's rotation shears away every feature that is not symmetric about the axis. The tilt, the wobble, the lumps, the flicker, all of it is filtered out, layer by layer, and what emerges on the far side, the only part any spacecraft can ever measure, is the ghost of the field, smoothed into perfect symmetry. The frosted glass passes the glow and erases the flames. If this picture is right, then Saturn is not violating Cowling's theorem, because the true field down in the dynamo is as crooked as the law demands. What Saturn has done is build, out of falling helium, a physical filter thousands of kilometers thick that launders its own chaos into the appearance of perfect order, and presents that appearance to the universe as its public face. I have been promising you all night that the calm of this planet is a performance, and here, at the level of fundamental physics, is the mechanism of the performance, made literal. The serenity is manufactured. There is an engine of chaos in the heart of Saturn. There must be. The mathematics accepts no alternative, and wrapped around that engine is a smoothing shell that hides every trace of it, so completely that our best instruments, flown to their destruction between the rings and the clouds, could not catch a single flicker of the mess that has to be inside. Say the old suspicion again, the one from the first chapter, and notice that it is no longer a suspicion. The quieter Saturn looks, the more it is hiding. At the pole it hides a tower of geometry. Under the haze it hides winds and storms beyond anything in human experience. And in its magnetic heart it hides the chaos itself, behind a veil that physics says must be there, precisely because what we see is too perfect to be real. Perfect order, it turns out, is not peace. On Saturn, perfect order is a mask, and the mask goes down for thousands of kilometers. Before we follow that thread, notice what this hypothesis quietly concedes, because the concession is bigger than the explanation. If the frosted glass is real, then the true magnetic field of Saturn, the actual crooked, living, flickering thing down in the dynamo, is not just unmeasured, it is unmeasurable. Not with better magnetometers, not with closer orbits, not with a century of patience, because the smoothing is not a flaw in our instruments. It is a physical process inside the planet, scrubbing the information out of the field before the field ever reaches the outside. There are hints of how we might someday catch the chaos leaking through. Tiny time-varying ripples in the field's fine structure that a future orbiter with a modern magnetometer might detect, and scientists have proposed exactly such tests. But as it stands, Saturn has done something no other planet we know has done. It has encrypted a piece of its own interior, and there is a small, strange postscript that makes the whole picture stranger. For all its perfection, Saturn's field is oddly weak at the cloud tops, weaker there than Earth's field is at the ground, even though the planet's total magnetic strength runs hundreds of times ours. Enormous, flawless, and faint, like a voice that carries across a continent but never rises above a whisper. Even the field's loudness is understated. Even the impossible thing is polite about it. And this mask has a cost, one that ripples all the way up to something so simple, so basic, that you would never guess it could be a casualty of magnetism. Because of that flawless, featureless, symmetric field, Saturn managed to conceal from the entire human species, through the whole era of spacecraft, a fact we knew for every other planet in the solar system. Until 2019, nobody on Earth knew how long a day lasts on Saturn. How long is a day? On most worlds, that is the easiest question in planetary science. For Mars, you watch a mountain cross the disk and time its return, and you have your answer to the second 24 hours and 37 minutes. For Mercury, you bounce radar off the rock. Even for cloud-wrapped Venus, radar pierces the veil and clocks the surface. A day, the spin of a world on its axis, is the most basic fact a planet has, the first line of its passport. And gas giants, though they offer no mountains to watch, were supposed to have an honest way of confessing it too. A giant planet's magnetic field is anchored in its interior, and because every normal field is tilted, the field wobbles as the planet spins, and that wobble whips through the radio emissions pouring from the planet's auroras, marking each rotation like a lighthouse beam sweeping past. Jupiter's radio pulse gives its day to within seconds, 9 hours and 55 minutes. When the Voyagers flew past Saturn, they listened for the same pulse, found a rhythm in the kilometric radio emission, and wrote down Saturn's day. 10 hours, 39 minutes, 24 seconds. The number went into the textbooks, and for a generation, That was that. But you already know the problem because you just spent a chapter with it. Saturn's field has no measurable tilt. There is no lighthouse lean, no wobble to sweep a beam. Whatever rhythm the voyagers heard, it was not the clean turning of a lighthouse. 23 years later, Cassini arrived with better ears and listened again, and the rhythm had changed. The radio period now came out near 10 hours and 47 minutes, roughly 6 minutes slower than the Voyager number. Understand what that would mean if taken at face value. A planet is a colossal flywheel. 95 Earth masses do not spin down by 6 minutes in 2 decades. The energy required would be beyond anything the solar system could quietly supply. A planet cannot change its day like that. So the day had not changed. The clock was lying, and then it got stranger. As Cassini kept listening year after year, it found that the northern and southern hemispheres of Saturn were broadcasting different radio periods, 2 rhythms at once, out of one planet. And both rhythms drifted with the seasons. Around the equinox of 2009 and 2010, the 2 periods approached each other, crossed over and swapped, north taking south's tempo and south taking north's, like 2 clocks trading their errors. 2 ticking rates, neither of them constant, neither of them equal to the other, coming from a single rigid world. The conclusion, once the community absorbed it, was as humbling as anything in the Cassini era. Saturn's radio rhythm does not measure the planet's rotation at all. It measures the slippage of the magnetosphere, the vast envelope of charged particles and field lines around Saturn, which turns almost with the planet but not quite, gripping and slipping like a clutch plate, dragged by seasonal winds in the upper atmosphere. The kilometric radiation is the hum of that clutch. It was never the spin of the body of Saturn. For 25 years, humanity's books listed a day length for Saturn that was, in truth, the tempo of a slipping clutch, and the planet's actual rotation remained unknown. Sit with the absurdity of that. Through the entire space age, through Pioneer and both Voyagers and 13 years of an orbiter parked on Saturn's doorstep, the 6th planet, visible to any shepherd on any clear night for the last 100,000 years, kept the length of its own day a secret. We knew the day of Mars to the second. We knew the day of distant, dim Neptune from a single flyby. Saturn, photographed 500,000 times, would not give up the first line of its passport. The featureless clouds hid every landmark. The perfect field erased every wobble. Every conventional door to the answer was not just closed but missing. It is difficult to find another example anywhere in astronomy of so basic a fact, about so prominent an object, staying hidden for so long. The answer, when it finally came, arrived through the most improbable door imaginable, and by now you may be able to guess it. The rings. Saturn's interior, like the interior of any star or fluid planet, is not silent. It vibrates. Enormous, slow oscillations ripple through the body of the planet, the whole world ringing faintly like a struck bell, each mode of vibration set by the structure and density of the layers inside. Those vibrations subtly shift Saturn's gravitational field, rhythmically, and the rings, that sheet of ice hanging weightless around the planet, feel every shift. At special locations in the C ring, where a ring particle's orbital rhythm happens to match one of the planet's internal vibrations, the resonance carves visible patterns, spiral waves winding through the ice, frozen music. Astronomers had noticed unexplained waves in the C ring as far back as the Voyager era, waves with no moon to blame. In 2013 and 2014, Matthew Hedman and Philip Nicholson proved what a few theorists had dared to suggest. The orphan waves matched the predicted oscillation modes of Saturn itself. The planet was writing its own seismogram into its rings, and Cassini's cameras had spent a decade photographing the printout. A new word entered the field: chronoseismology, the seismology of Saturn, an entire science conducted by reading a disk of ice. Because the vibrations rise from the interior, they carry the interior's fingerprints, including the one number nothing else could deliver. In 2019, Christopher Mankiewicz and his colleagues fitted models of Saturn's structure to the ring waves and extracted at last the true rotation of the deep planet. 10 hours, 33 minutes, and 38 seconds. Several minutes faster than the number the textbooks had carried since Voyager. That is the real length of a day on Saturn, and mark the date. 2019. Galileo saw the rings in 1610. The first close spacecraft measurement was 1980. We did not learn how long a day lasts on Saturn until 7 years ago, and when we finally learned it, we learned it not from the planet, which never volunteered a single honest tick, but from the testimony of the rings, the same rings the planet is quietly devouring. The witness for the prosecution, it turns out, is the victim, and the ring waves were not finished testifying. In 2021, Mankiewicz and Jim Fuller pushed the analysis deeper, because the specific mix of oscillation modes recorded in the C-ring depends on what the middle of Saturn is actually like, and the recorded mix refused to match a planet with a neat, compact core. The waves demanded something else. Saturn's core, they found, is not a discrete ball of rock and iron with an ocean of hydrogen sitting on top of it. The tidy layered picture generations of diagrams have drawn. Instead, the centre of Saturn is a blur. Rock and ice, about 17 Earth masses of it, is smeared outward through the metallic hydrogen in a gradual gradient, densest at the centre and thinning with height, with no boundary anywhere, a so-called fuzzy core that extends through roughly 60% of the entire radius of the planet. Imagine slicing Saturn open and looking for the place where the core begins. You would never find it. You would find, over a span wider than 7 Earths set side by side, hydrogen becoming slowly soupier, heavier, richer in stone, with never a flaw, never a line, never an inside you could point to. The descent with no landing that we imagined through the clouds continues all the way to the centre of the world. Even at its heart, Saturn refuses to have a surface. Even its core is a concealment, hidden not behind a veil this time, but behind the absence of any edge at all. And a smeared, layered, partly stable interior like that is exactly the environment that nurtures the stratified helium shell from the last chapter. The frosted glass around the dynamo. The blurred core, the helium rain, the silent symmetric field, the falling rings heating the upper air, these are not a list of separate curiosities. They are beginning to look like organs of a single body, a planet whose every layer, from the cloud tops to the centre, is arranged to keep its own workings out of sight. Step back and look at the pattern of this chapter, because it completes something. To learn the weight of the rings, we had to fly a spacecraft between the rings and the planet. To learn the length of the day, we had to decode vibrations written into a sheet of orbiting ice. To learn the shape of the core, we had to read the same ice again, more carefully. Nothing about this planet has ever been learned the normal way. Every basic fact had to be pried out sideways, through some improbable back channel, because every front door is sealed, and nearly all of those back channels ran through one machine, in its final months, on trajectories so dangerous they were only approved because the machine was already condemned. The evidence of this entire video was purchased in a single summer by a spacecraft with a scheduled death. It is time to go back to September of 2017 and watch what the knowledge cost. The decision to destroy Cassini was made by the people who loved it most. That is the detail worth holding on to as we enter this final act of the mission story, because it is easy to imagine the end of a spacecraft as a failure, a loss of control, an accident at the end of a long road. This was the opposite. This was a choice, weighed for years, argued over conference tables by scientists and engineers who had, in many cases, spent their entire professional lives with this one machine, and who chose, with full knowledge, to end it. The reasons were the moons. Cassini itself had transformed Enceladus from a minor bright snowball into one of the most promising abodes for possible life in the solar system, a world with a warm, salted ocean under its ice, venting into space through geysers the spacecraft had actually flown through and tasted. Titan II had become a world of rivers and rain and organic chemistry, and Cassini, aging, could not be left to tumble blind among such places, carrying its plutonium and its cargo of dormant Earth microbes. Someday, decades or centuries on, an uncontrolled Cassini would strike something, and if that something were Enceladus, humanity might never again be able to ask cleanly whether that ocean held its own life, because we would have seeded it with ours. The mission's guardians did the responsible arithmetic, and the arithmetic said, while you can still steer, burn the ship. But the sentence came with a gift, and the gift reshaped this entire video. A condemned spacecraft can be sent where no healthy one would ever be risked. Between the inner edge of the rings and the top of Saturn's atmosphere lies that gap of roughly 2,000 kilometers, a corridor no machine had ever entered. And inside that corridor, as it turned out, lived nearly every answer this video has leaned on. So in April of 2017, Cassini used one last close pass of Titan to bend its orbit inward, and began the sequence the mission named the Grand Finale. 22 orbits, each one threading the needle between the planet and its rings, at speeds above 120,000 kilometers per hour. A passage so tight and so fast that a collision with a single stray centimeter of ring ice could have ended the mission mid-dive. 22 times the spacecraft crossed the corridor, and 22 times it emerged, carrying data that could have been gathered in literally no other way. It was inside that gap that the radio tracking teased apart the gravity of the planet from the gravity of the rings and produced the ring mass, the number that made the rings young. It was inside that gap that the mass spectrometer tasted the equatorial rain, the falling ice and methane and organics, and turned an inferred drizzle into a measured torrent. It was inside that gap that the magnetometer, closer to Saturn than any instrument in history, measured the tilt of the magnetic field at less than 1/100th of a degree and handed theoretical physics its most elegant planetary problem. The three pillars of tonight, the dying rings, the forbidden field, the hidden interior, every one of them was quarried out of that 2,000-kilometer corridor in 5 months by a machine flying between a planet and its rings on borrowed time. The mission saved its greatest science for the road to its own funeral, and the road ran 22 laps. The first lap tells you everything about the nerve this required. On April 26, 2017, nobody on Earth knew what was actually inside that corridor. The model said the gap should be largely clear of ring debris, but models had been wrong about Saturn before, and at these speeds, a fleck of ice the size of a grain of sand carries the punch of a bullet. So for the first crossing, the flight team turned the spacecraft around and flew it in backwards, using the great 4-meter dish of its main antenna as a shield, the instrument that talked to Earth repurposed as a riot shield held out in front of the ship. For 20-some hours after the dive, while Cassini was turned away and silent, nobody on Earth knew whether it had survived. When the signal finally came through, the spacecraft was fine, and the data held one more surprise, so in keeping with everything else tonight that it is almost funny. The corridor was quieter than predicted. The instrument built to hear dust impacts registered almost nothing, a near silence so unexpected that the project scientists publicly called the region the Big Empty. Even in the one place where Saturn was expected to be dangerous, it turned out instead to be eerily, inexplicably calm, and the calm itself became a scientific puzzle. The planet stayed in character to the very end, and then the fuel gauge, which had dictated everything, dictated the date. The last full day was September 14, 2017. Cassini spent it saying goodbye in the only language it had. It photographed Titan, the moon whose gravity had steered it for 13 years, one final time. It photographed Enceladus, the world it was dying to protect, setting behind Saturn's limb. And it took a last long look at the planet itself, the rings half lit, the globe in twilight. Then, in the early hours of the 15th, the cameras were switched off forever, and the spacecraft turned itself into what it had been at the very beginning, an antenna pointed at Earth. There would be no pictures of the end. Every remaining watt was given to the radio so that the final plunge would be transmitted live, measurement by measurement, until the last possible instant. The machine that had spent 2 decades looking at Saturn spent its final hours looking home. Now come stand in the room where it ended, because this is a scene humanity should keep. It is the middle of the night in Pasadena, California, September 15th, 2017, and mission control at the Jet Propulsion Laboratory is full in a way it has rarely been full. Veterans of 2 decades crowded behind consoles, families in the visitor gallery, coffee going cold. On the screens, a green trace rides steadily along, the carrier signal of a spacecraft 1.4 billion kilometers away, falling toward a planet at 34 kilometers every second. The room is quiet, and the quiet has a strange double exposure in it, because everyone present knows 2 times at once. On the screens, Cassini is still alive, still transmitting, but light takes 83 minutes to cross the distance, and so everyone also knows that out at Saturn, in the world of events rather than signals, the spacecraft has already been gone for more than an hour. They are listening to a ghost, watching the last light of something already ended, and no one can do anything but watch it arrive. Out there, 83 minutes in the past, the story is playing out. Cassini strikes the top of the atmosphere, a place it was never built to fly, and the thin air begins to shove it. Small thrusters fire to hold the antenna on Earth, 10% of capacity, then more, then bursts at full throttle, the machine fighting with everything it has, not to save itself. That was never the plan, but to keep talking for a few seconds longer. For about 91 seconds it holds the line against a planet. Then the air wins, the spacecraft begins to tumble, the antenna swings away from Earth, and in Pasadena, at 7:55 and 46 seconds in the morning, East Coast time, the green trace on the screen drops away and does not come back. The program manager, Earl Mays, stands at his console and says it plainly. The signal from the spacecraft is gone, and within the next 45 seconds so will be the spacecraft. He calls the end of mission, and the room does the only human thing there is to do. It applauds, and then the applause breaks into embraces, and there are people at those consoles, grey-haired engineers who joined the project in the 1980s, standing in front of the whole world with tears running freely, holding each other like family at a graveside. Somebody in that room had spent 30 years on this machine. For them, this was not the end of a project. It was the death of a colleague. As for the spacecraft itself, its ending took under a minute. Tumbling, glowing, coming apart, it streaked through Saturn's morning sky as a meteor, its aluminum and titanium and instruments and its half-empty tanks flashing into vapour, every molecule sterilised exactly as intended, and the vapour thinned and cooled and drifted and mixed into the clouds. Which means the story closes on the quietest possible image. Cassini did not leave Saturn. Cassini became Saturn. The machine that weighed the rings, tasted the rain, timed the storms, and caught the impossible field is now a fine ash dispersed through the upper atmosphere of the planet it studied, orbiting with the winds it once measured, part of the golden haze in every photograph we will ever take from now on. The witness is inside the mask. One more thing belongs in this chapter, because you will meet it if you ever search for this story online. There are claims, repeated every year, that the plunge was a cover-up, that the spacecraft was destroyed to hide something it had found. The record answers this better than any argument. The disposal decision was announced years in advance, debated publicly, and executed in front of a live global audience, and every byte of data from the final plunge, down to the last fragmentary measurements, was released openly and remains available to anyone. Nothing was hidden. The truth is both stranger and kinder than the myth. The people who ran this mission burned their own life's work deliberately to protect 2 small moons on the chance, only the chance, that something might be alive there. Humanity has done few things at Saturn, but that one was worthy of the place. So now every piece of the case is on the table, and the price of each piece is paid and known. A drained crown, a geometric tower, a curtained fury, an encrypted field, a day kept secret for 40 years, and a witness dissolved into the sky it studied. All that remains is to assemble it, and to answer, finally and directly, the question this entire night has been building toward. Why is Saturn, of all the worlds we know, the scariest planet, and why is it not even close? Every planet in the solar system tells you what it is. That is the remarkable thing you notice once you start comparing honestly. Jupiter is violent, and Jupiter shows you its violence, wears its 400-year-old storm like a badge, churns its chaos in full view of a department store telescope. Venus is hostile, and Venus is frank about the manner of its hostility. It hides its surface under permanent cloud, yes, but it hides everything equally, an honest opacity, and when our radar finally looked through, what we found, crushing pressure and furnace heat and acid sky, matched exactly what the clouds and the numbers had warned us to expect. Mars is legible to a fault. Its whole biography, the dry rivers, the dead volcanoes, the lost ocean floors, lies open on its surface for any orbiting camera to read like a diary left unlocked. Mercury is a scorched fossil, and looks like one. Uranus and Neptune are strange, tilted, windy, and their strangeness is right there in the first measurement. Fields askew, axes wrong, nothing concealed because nothing is orderly enough to conceal anything. Every one of these worlds, whatever its dangers, gives its nature away. The solar system, surveyed world by world, is a collection of honest witnesses. Then there is Saturn. And now, at the end of the night, we can finally lay out the full ledger of what Saturn shows you and what Saturn is, and let the gap between the 2 columns speak for itself. Saturn shows you permanence, the one structure in the sky every child would swear is eternal, and the truth is that the rings are a temporary event, younger, quite possibly, than the grass, assembled from the wreckage of a moon, The planet tore apart and draining away into the planet at up to thousands of kilograms every second through a rain that no camera can see. Saturn shows you serenity, the softest, calmest face of any giant, and the truth is that the calm is a physical curtain of haze drawn across winds 4 times faster than anything Earth has ever recorded, and storms that circle the entire planet and strangle themselves with their own tails, a fury that erupts once a generation, and is then wiped from the visible record as if it had never happened. Saturn shows you geometry at its pole, order so crisp it looks drafted, and the truth is that the geometry is a half-explained tower of wind that has ignored 40 years of seasons, duplicated itself into the sky above it, declined to appear at the other pole, and never once told us why 6. And Saturn shows you perfection in its deepest signature, a magnetic field aligned beyond our instrument's power to find fault, and the truth, according to the oldest theorem in dynamo physics, is that this perfection cannot be real, that a churning engine of chaos must be turning underneath it, and that the planet has built out of falling helium rain a shell whose entire function is to erase the evidence, to launder disorder into a flawless public face. Even the small facts follow the pattern. The water is buried below 160 kilometers of cover. The day length was withheld from the entire space age until the rings betrayed it. The core, when we finally reached it with mathematics, turned out to have no edge at all, a blur filling 3/5 of the planet, so that Saturn does not even contain a place you could call its inside. Column A, the appearance. Column B, the measurement, and no 2 columns in planetary science disagree like Saturn's. That is my answer to the question in the title, and I want to state it as plainly as I know how. Saturn cannot hurt you. It is 1.5 billion kilometers away, and nothing about it reaches us but light 80 minutes old. Saturn is not the scariest planet because it is dangerous. It is the scariest planet because it is dishonest. Every other world's face is a fair summary of its facts. Saturn's face is a mask, and it is not one mask but a nested series of them. The haze over the storms, the shell over the dynamo, the brightness over the ring's age, the missing edge over the core, the false radio tick over the true day, masks all the way down, and behind the last mask we have reached there is still more planet we have never seen. What frightens in the end is not violence. Violence is legible. What frightens is composure that will not crack, calm that deepens the harder you press on it. Saturn is the only world we know that has that composure, the only one whose serenity is load-bearing, engineered, maintained at every level from the cloud tops to the centre. The scariest planet is not the one that screams. It is the one that smiles, and has been smiling for 4 billion years, and has never once meant it. And no other planet is even close, because no other planet needs to be dishonest. They put their chaos on the outside. Saturn keeps its chaos where the theorem says it must be, locked behind frosted glass, and shows the universe a perfect, silent face. Now, I have been building this case all night like a prosecutor, so before we rest, honesty requires giving the defense its closing argument too. A careful scientist would say that scary is a word about us, not about the planet. Saturn is not performing for anyone. It is simply a world in a regime our intuitions never trained on, and every mystery in this video is an active field of research, not a haunting. The rings are young because a moon wandered too close. The hexagon is a jet stream instability we can already conjure in a spinning tank of water. The perfect field is a stratified layer doing exactly what stratified layers do. Give the science another century, this argument runs, and Saturn will be as legible as Mars, and tonight's unease will seem quaint. It is a good argument, and most of it is probably true, and I want you to notice that it does not actually remove the strangeness. Look at what the comforting explanations themselves assert. They assert a planet that eats a moon and wears the crumbs as jewellery, a planet whose own atmosphere spontaneously draws geometry and holds the pose for decades, a planet that physically manufactures its own inscrutability, that filters its magnetic field into a shape mathematics forbids, that hides its water, its day, its interior, its history, not through anyone's intention, but through the blind operation of its own structure. The defense does not acquit Saturn of wearing a mask. The defense merely proves the mask grew there naturally. I am not sure that is more comforting. A world that chooses to hide would at least imply something understandable behind the choice. A world that hides automatically, effortlessly at every layer, because hiding is simply what its physics does, is stranger than any intention. The truth about Saturn is not that it keeps secrets the way a person does. It is that Saturn is built out of secrecy, the way other planets are built out of rock, and of all its concealments, the one I find myself returning to here at the end is the one that involves you. The rings are leaving. That is as certain as anything in this video. The rain we discovered in the 3rd chapter has been falling through every sentence since. It fell while we walked the Hexagon's walls. It fell while Cassini burned. It is falling now, this second, as you lie there listening, a silent sleet of ice sliding down invisible field lines into the golden clouds, and it will still be falling when you wake, and when everyone now alive has gone, and it will not stop until the sky's most famous ornament is entirely inside the planet it once adorned. On the long calendar of the sun's family, bright rings around Saturn are a brief flash, perhaps 2% of the story, and every eye that has ever seen them, Galileo's at his window in Padua, Huygens's, the engineers at their consoles in Pasadena, and yours, whenever you last looked, all of them opened inside the same thin flash of time. Nobody before the flash ever saw the rings. Nobody after it ever will. The dinosaurs missed them. Whatever comes long after us will miss them too, and will perhaps never quite believe the old images, the gas giant wearing a perfect circle of light. We are not late to Saturn, and we are not early. We are, by pure unearned chance, exactly on time, guests at a spectacle the universe is already in the process of taking down. So here is the closing thought, the one to carry down into sleep. Some night soon, find Saturn. It is easy. Any stargazing app will point to it. Any small telescope will show you the rings, hanging there exactly as they hung for Galileo, looking like the calmest, most permanent, most finished thing a sky could hold. Look at it for a while, and know everything you now know. The rain falling inside the light, the 6-sided tower turning at the crown, the chaos humming behind the flawless field, and a machine's ashes riding the golden clouds. Saturn swallowed its children, and it is swallowing them still, so slowly and so gracefully that 4 centuries of watchers never caught a glimpse of the act. The quieter Saturn looks, the more it is hiding. That was our suspicion at the start of the night, and it is our verdict at the end, and it is why, of all the worlds circling all the stars we will ever name, the scariest planet we have yet found is the beautiful one, the calm one, the one every child draws. It is Saturn, and it is not even close. And if that thought follows you towards sleep tonight, let it arrive gently, less as a fear than as a question, the kind this universe seems endlessly willing to supply. Because the sky is full of calm and lovely things, and we have now looked closely at exactly one of them.